All right, here we go. Welcome to video 1.1. We're going to be learning the difference between distance and displacement today. All right, so here we go. Two definitions. First of all, distance. Symbol for distance is a lowercase letter d, and it is the total length of the path that an object follows in some time interval. Okay, displacement is very similar because it's also going to be a length, just like distance is a length, displacement is going to be a length. But it measures something different. So here's what it is. Displacement. The symbol for displacement is a triangle followed by the letter X. We'll learn why those symbols are chosen in a minute, or actually in a couple of days. But displacement is this whole thing. Triangle X means displacement. All right, and it is the length and direction. I'll fill in this direction thing in a minute. But it's the length and direction of the straight line from an object's position at one time to its position at another time. Okay, so distance is the total length of the path. Displacement is the length of the straight path from start to finish. Okay, so probably easiest to see by doing an example. So here we go. Here's an example. It says, suppose an ant is sitting on the screen here and he crawls from point A to point B by following the solid black line shown here. So I'm actually going to, all right, so here we go. Our ant is right here at point A, right, hanging out, and he's going to crawl to point B. However, he is not going to walk in a straight line, and so he follows a path like this. It's all curvy, he's wandering around looking for some more peanuts to eat, or beans, or whatever that thing is there. He crawls around and ends up there at point B. Okay, so the total length of that path there would be his distance. If you imagine grabbing the two ends of that line and pulling it straight like a piece of string, the total length of that line would be the distance. Okay, so in this example on my board, that distance could be, I don't know, maybe even 10 feet. I don't know, it looks like it's pretty long on my smart board here. Okay, but whatever, he walked a long ways, right? And at the end of the day, he's going to be tired because he walked, you know, that big long curvy path. Now, displacement is different. Displacement is the length of the straight line from point A to point B. So it doesn't care how the ant got from point A to point B. All that displacement cares about is the fact that we started at A and ended at B. And so the displacement would be the length of this line right there. Okay, that goes all the way over to point B. So it's this. All right, that is the displacement. All right, it's going to be shorter, right? Because the displacement's the straight line between 2 points. All right, so if I was to measure that with a ruler, it might be, I don't know, 4 feet, something like that. Okay. So there you go, distance and displacement. The distance is the total length of the path you follow. The displacement is just how far it is from your starting point to your ending point. It doesn't matter how the ant got there. Okay? So I want you to notice a couple things. First of all, the distance cannot possibly be shorter than the displacement because the shortest path between 2 points is a straight line. Okay, so your displacement is always less than your distance, or at best, it could be equal. The distance and displacement could be equal if the object travels in a straight line. Check it out. If you've got, you know, a bug or something that's going to crawl from here to here, since that's my starting and ending point, automatically my displacement is that dotted line, right? So that's my displacement. The only way the distance would be the same thing as if the ant or bug crawled in a straight line, right? Okay. All right, and then finally, the dotted line, displacement, has an arrow at the end. Okay, going back to this, we had a dotted line here. You guys probably can't see it because it's pretty small, but this dotted line has an arrow at the end to indicate where the ant's starting position was and where its ending position was. All right, that indicates the direction, right? Because remember, I told you guys that when we talk about displacement, it includes direction. Okay, and that's how we indicate it with that arrow over here, right? Okay. So now, because displacement includes direction, we're actually going to use sort of a different convention to keep track of this. All right. You know, if your ant walks 4 miles west, you can't type west into a calculator. So here's what we're going to do. We're going to do the same thing we do in math class. Everything we do this chapter is going to be linear, which means that all of our motion is going to take place either on the x-axis or Other examples will take place along the y-axis. Okay, so if they take place on the x-axis, then anything to the right is positive, anything to the left is negative, and on the y-axis, anything up is positive, anything down is negative. Okay, which means to us that if we go east, that's got to be positive, whereas west is going to be negative, right? If you've got an ant that is crawling forwards, that's going to be positive. If he's going backwards, then it's negative. If the ant is crawling up a telephone pole, that is positive. If he's going down, that's negative. If you've got somebody going north on a road, that's positive, and south on a road would be negative. Okay, so make sure you're writing this stuff down, okay, because this will come up again and again, and people will say, why did you make that negative? And the reason that I made it negative is because it was traveling west or whatever. Okay, so now okay, sorry about that. I realized I had to tweak my slides. Okay, sorry. So here we go. So let's do a couple examples with some actual numbers. We're going to start out with some simple ones. So in the first examples, we're going to do the object moving in a straight line. So notice, if the object moves in a straight line, then your distance and displacement are the same. The only difference is that the displacement might be negative. Displacement might be negative. Otherwise, they are the same if the object travels in a straight line. Okay, and we can see that in this next example. Oh, Roy walks 4 miles west. So he's going to start here, and he's going to go 1, 2, 3, 4 miles west. Okay, so in that case, the distance he walked is, phew, I'm tired. I walked 4 miles is what he's going to say, right? But his displacement, the distance from starting point to ending point, is also 4 miles, but because he went in a negative direction, we need to make our displacement negative. Okay, so as long as you go in a straight line, the distance and displacement are the same. That can also be illustrated on a number line. All right, so look at this. We've got this little world here with Roy's house and White Castle and Sally's house. Let's say that each of these marks is a kilometer. Okay, so the distance from Roy's house to White Castle is 3 kilometers, for example. All right, so but in this example, Bob is going to walk from his Triangle store to the White Castle. So he's going to walk from the Triangle store to the White Castle. So he's going to walk from there to there, right? So we need to figure out the distance he walked and his displacement. Well, they're going to be the same thing because he walked in a straight line. Again, my displacement is going to be negative something. We just got to figure out how far, right? So to find out how far he walked, we got to count. So let's do it. Let's count. He's going to walk 1, 2, 3, 4, 5, 6, 7, 8, 9 miles. Or the displacement would be negative 9 miles. The only reason I wanted to do this example is I wanted to caution you, because notice how I did this. I counted spaces. See that? That's 1 mile, 2 miles, 3 miles, right? You can't count numbers. Every once in a while I'll get somebody who does this. They'll go, oh, well, he started here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That doesn't work, okay? Because when he's here, he hasn't gone anywhere yet. And he hasn't gone 1 until he gets to 11. Okay, so there's his distance and his displacement. Notice, again, they're the same. The only difference is the displacement is negative. Okay, so what happens if he doesn't go in a straight line? Bum, bum, bum. So here we go. Suppose Roy walks 8 miles west, and then he goes 3 miles east. So here's what's happening. He's going to start here, and he's going to go 8 miles west, and then he's going to turn around and go 3 miles east, right? So the distance is pretty straightforward. Just how far did you walk, Roy? Well, I walked 8 miles west, then I turned around and went another 3 miles, so I went a total of 11 miles. Notice I don't have to worry about negatives or anything, right? Because distance is just how far you went, all right? With displacement, you got to keep track of your direction, right? So for my displacement, it's going to be negative 8 miles, right? Because this 8 miles is to the west, so I got to make that negative. okay? And then I went 3 miles east. Since east is positive, I'm just going to add 3. And then you grab your calculator and you do -8 plus 3, and you get -5 miles. Okay? So that's how to find the displacement. But what does it mean? Well, remember, displacement is the distance from start to finish. So this -5 miles that I just got here is this. It's how far it was from start to finish. Okay? And hopefully that makes sense, right? Because look, if the long red line is 8 miles and the little red line is 3 miles, then it makes sense that this should be 5 miles. And the reason that it came out negative is because he ended up to the west of his starting point. Okay? And I believe we have just a couple more slides here. We're almost done. All right, so now we're back to the number line. This time, Bob is going to walk from the Triangle store to the Quickie Mart and then to Sally's house. We need to find the distance and the displacement. So he's going to walk from the Triangle store to the Quickie Mart. So there's the red part. And then he's going to walk from the Quickie Mart all the way back to Sally's house. Okay, so to find the distance, I need to find the total distance he went. Well, for the red part, he walked from 12 to 15, right? I neglected to show you that on the previous slide. Okay, well, let's do this. Let's jump back. Boom, boom, here. Notice we got 9 miles, didn't we? Well, let's think about this for a second. We got 9 miles, right? Well, look, what was the starting position? Starting position was 12, right? Right, miles, kilometers. I guess let's make these miles since I keep saying miles. All right, so starting position was 12 miles. Ending position is 3 miles, right? What do you notice about those? What do you get when you subtract them? Don't you get 9 miles? All right, so that's how you can find the distance between 2 points on a number line, just by subtracting the 2 numbers. Okay, so that's what we're going to do up here. Look, our dude, Bob, is walking from 12 to 15. So what's that distance? Looks to me like it's going to be 3 miles, right? The difference between 12 and 15. So 3 miles plus, how about the blue part? Well, in the blue part, he's walking from 15 to 7. So what's the difference between 15 and 7? Let's see, 15 minus 7 gives you 8 miles, right? So if you add those up, you get 11 miles. I think that's what we got before, isn't it? All right. Now, to find displacement, same idea, but this time we got to keep track of negatives. So let's see, the 3 miles was this way. So that's positive 3 miles. Plus the 8 miles is this way. So the 8 miles is actually negative this time. And so you get an answer of -5 miles. That is just a weird coincidence, and I got the same answers as I did in the previous example. Okay? So, I believe that is what you need to know. All right, so this one, what I'd like you to do, I'd like you to copy this example down right now. See if you can answer it. I'm going to not answer it right now. We will talk about it in class when I see you next. Okay? Before I end, one quick note about units. I, throughout this video today, have been using miles to measure my distances and my displacement. And in one case, I mistakenly used kilometers. All right? But you can use any of these, okay? Both distance and displacement measure length, okay? And units that you can use to measure length are inches, feet, yards, or miles in sort of the standard English system. Or in science classes, we tend to use the metric system. So you could use centimeters, meters, or kilometers. Eventually, once we get rolling in this class, we are going to be using almost exclusively meters. Okay? And so that is what you need to know. I think we are done. Next video is going to be speed and velocity. You are fired up. All right, here we go. Let me see, how do I stop this thing? Look at that, 15 minutes.